Hello, fellow problem solvers. So there I'm doing a practice problem from number theory, which I suggest you try out for a minimum of 45 minutes, ideally an hour and a half, 2.5 hours, do not more than 4 hours. This is a great number theory problem to practice your, number theory, combinatorial number theory, problem solving skills. So without further ado, if you'd like to go along with us, give this a go for the next 10 minutes. And now let's begin. So we have this sequence defined by, 1, 8, 2. Okay, so every other member is either +1 or -1 of the previous one if the, depending on the greatest odd divisor of n. Okay, and we need to prove that every natural number shows up an infinite number of times. Here the natural numbers are 1 through infinity. 0 is not a natural number, not in this room, not in this class. So what do we have here? So every natural number shows up an infinite number of times. Well, okay, you need to ask yourself, what is then enough for us to prove here? And the answer is there's two claims. One is that from here it follows that 1 shows up infinitely many times. Right? If this is true, then 1 shows up infinitely many times. But the second thing is, if this is true, then we'll have any natural number needs to show up. I'm thinking like if every natural number shows up once, will show up an infinite number of times. If I have 1 that shows up an infinite number of times, and every natural number shows up at least once, does that mean that I think that means every natural number shows up an infinite number of times. And here's why. What this means is that for any n, there exists an n greater than this, capital N, such that a n is equal to 1. And now we know in the sequence that the number n plus 1 also shows up. So it could not have showed up here, or say n plus 2 just to be on the safe side. Actually, n plus 1 could not have showed up here because we have a 1. A 1 is 1. So it must show up somewhere later down the line. So then we'll get to n plus 2 at some point, and then we'll pick up all the other numbers again. So I think those two claims are sufficient due to that. That 1 shows up infinitely many number of times, and that every natural number shows up at least once. So now how are we going to go about this? Well, let's first, what happens when you don't know what to do? As I don't know right now. I've had this on a test a long time ago. I don't remember what I did, whether I did it or not. So the first thing is like, I have no idea what I'm going to do. Then what do? Well, I write down the first couple of problems, and I invite you to pause for the next 10 minutes and try to do that. So here's what I have. I'll have n, and I'll have an, and I'll have the odd divisor, just how I like. So for n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just see how this goes. So the odd one is here 1. It's 1 again. It's 3. It's 1. Let's just say it's like 4k plus 1 or 4k minus 1. So here's 1, 1, 3, 3. Then it's 6 times, so it's a 3. Then 7 is of the form 4k minus 1, so it's a 3 again. Actually, wait, 5 is of the form 4k plus 1, my bad. 8 is of the form that 1, 9 is a 3, 10 is the same as 5, which is a 1, then 11 is a 1. So one thing I'll have is when I get the odd numbers, I'll get 12, 13. So every time I'll get the odds, I'll have 1 and minus 1 will alternate, or 1 and 3 will alternate. Now the question is what happens on the even numbers? That is, I think, where the crux of the problem is, because on the evens I get a 1, a 3, a 1, a 3. And this 3 is tied to this one. This one is tied to this one, which is tied to this one. And then this one is tied. And you always go by half of 2n. Is what matters to you when you're looking at evens. The 10 is tied to a 5. 12 is tied to a 6, which is a 3. Right? 10 is tied to a 6. The 14 is somehow tied to 7, which is 3. Now let's see what an is. So it's then 1. I'm going to have plus 1 is 2. Minus 1 is 1. Plus 1, 2, 3, 2, 1. Then we're going to have 2. What I'm noticing here is this is both 2 to the power of n minus 1. Might be important, might not. It might be I'm like overemphasizing a pattern here. Maybe that's not the pattern. But it could be. Like you make these hypotheses while you're solving these problems. So then there's a 1, and then we have a 2, 3, then we have a 2, a 13 gives us a 1, and then a 14 gives us a 2, a 15 gives us a 3. So this pattern of 2 to the k minus 1 doesn't end up working. So we have 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 3. And 15, 16 gives us a. So it's a 1 again, so we get a 4. I was really hopeful for the powers of 2, but right now it doesn't seem like they're doing much for me. So what do we have? Do you notice anything here? I, in particular, do not. I mean, at this point, I don't. So what are we doing here is the question. How are we going to go about this? Why does 1 show up so many times? Say I have 1 showing up for some n. Say an is equal to 1. Why is the next one going to be a 2? So if an was equal to a 1, that means the previous that, n minus 1, was divisible by an odd number. I'm also not thinking about, wait, 1 shows up for 7, for 3, for 1, for 9, for 13. It shows up at odds. Could that matter in some way, somehow? How are we going to go about this? So these odds alternate. We know that a 4k minus 1 is going to be a 4k minus 2, and then minus 1. And a 4k minus 2, we don't know what that's going to be, but a 4k minus 3 is equal to a 4k minus 4 plus 1. And now, how does this thing here, which is going to be of the same plus or minus, I'm going to have actually a 4k minus 2 minus a 4k minus 3 will be the same as a 2k minus 1 minus, this is a 2k minus 1. That's its odd divisor. I'm thinking, can I say anything of this form, right? That this minus this will be the same as something here. So maybe I need to look at odds and evens cases to figure out what's happening here. Let's say a 8k minus 2. Let's just put 8k plus 6 because now I'm dealing with minuses in my head. So this is going to equal a, because this is 2 times 4k plus 3. So 4k plus 3 is the biggest one, so it's going to be 8k plus 5 minus 1. then I have a 4k plus 3 is a 4k plus 2 minus 1. So this minus this is equal to this minus this in this case. Well, 8ak plus 2 is equal to a 8k plus 1 plus 1. Then 8ak plus 4 is equal to a 4k. Actually, a 4k plus 1 is the same as a 4k plus 1. So it seems to be, to me, at this moment, that there's something here. Maybe there's something here I could use. A 8k plus 4 is off the form 4 times 2k plus 1. So I don't really know what this looks like. But I'm thinking, could this be useful? This actually might seem to bring me down to like the smaller levels. Now, the hypothesis here really is that a of, so this is an even, a of 2k minus a of 2k minus 1 is the same as a of k minus a of k minus 1. This is my hypothesis now. Which is saying if this is of the form, like this is either plus or minus 1, right? And I think if I can prove something like does something like this hold true? For example, let's take 10 minus 9. It's like, this is 1, 2 minus 1. 5 minus 4 is again 1. Now it doesn't work if I take now 4 and 5, I can't go 2. Like it doesn't work odd minus even. Could it be maybe that it's the opposite if it's odd minus even? I don't, like, let's double check again. Like 12 minus 11 is 6 minus 5. Wait a second, this is 2 minus 1. This is 3 minus 2. Could I be getting, and this gives me a 12 minus 11 was 2 minus 3. 2 minus 3. Like, why are these the same? 14 minus 13 is 7 minus, wait, 14 minus 13, I guess this is a contradiction to our rule, is 2 minus 1. And here we have a 7, which is, wait a second though, I might have messed up something else. 12 is a 3, 7 gives us, 7 is of the form 4k plus 3. Wait, but this then should be of the form 4k plus 3. I feel like I might have messed up somewhere in my table now. That is, I must say, this is the worst thing that can happen to you, like when you're like double checking where you messed up. And I invite you here to pause for another, 20 minutes and try to push the problem further while I find out where it is I've messed up. And this is how you come up with these solutions, like you're testing stuff out. I don't know if this works or not. I'm testing it out. I'll see. I'm forming hypotheses based on sort of like what I'm seeing here, and then maybe something based on these rules, because the even ones are messing with it. It's like the numbers a2 till a2k, all the even ones, are going to have the same plus and minus signs as the numbers 1 through k, a1 through ak. Like the same ordering of plus 1 and minus 1. And now I'm thinking, like, does that have something to do with this? And then those numbers I can again divide to odds and evens, and could I build them up somehow? I invite you actually 20, maybe 30 minutes even. Go ahead and pause, and here's the next step. So this is what it looks like now when you actually stop and pause and you try to figure out what is happening with the problem. I figured out that the mistake was at a 9. It was supposed to be a 1, not a -1. And now what I see is that this pattern that I saw before, that 2 to the n minus 1 is where the 1s are, actually does work out. And now the question is, how are we ever going to prove that? And this thing right here is an obvious statement now. When I think about it, it's, it checks out. And it's also trivial because it says that A2k and AK have the same highest odd divisor. That's kind of self-evident here. So with that in mind, the question is now, how are we going to prove that ones show up infinitely many times? And the idea is maybe, let's use induction here. Let's take advantage of these facts that we have. And I think for me, the induction I would use is that a 2 to the n is equal to 2 for every single one of these n's. And then because 2 to the n minus 1 is going to be plus 1 for there, like that might be an easier thing for me to prove. And why do I feel that way? Well, I know that the numbers, if I look at 2 to the n plus 1, let's say 2 to the n plus 2 till 2 to the n. These odd numbers alternate between ones that are plus 1 modulo 4 and the ones which are minus 1 modulo 4. And I can pair them up and their sums cancel out, right? That's the big idea here with the odds. You can just forget about them because you're minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, dum, bum. And then these numbers are the same, have the same sort of pattern as 2 to the n plus 1, all the way till 2 times 2 to the, actually this is 2 to the n minus 1 plus 1. This is 2 to the n plus 1, so 2 times 2 to the n. So from here to here, it's going to be the same pattern of, so here from these evens are going to be having the same patterns of plus 1s and minus 1s as these numbers have had. And now inductively, I know that these numbers, I'll think like my induction will go like this is equal to 3, this is equal to 2. And then via induction, I'll have that the difference between this number and this number is equal to what? Like that is the difference between their sort of pluses and minuses when you add them all up. And the difference between this one and this one is equal to the difference between, say, an 8 and a 5, which is minus 1. So the difference between this one and this one is also minus 1, which tells me, given I know inductively this is 2, this is 3, I'll also have then this is equal to 3. And then because the plus and minuses cancel out, then this is equal to 2, which forces the previous one, which means that 2 to the n plus 1 minus 1, a of this, is equal to 1. So that's the sort of thinking that goes on here. And now mind you, I'm also looking at where's the next, what is the first time the biggest number appears? And I see that for every single, I have this pattern, 1, 2, 5, 10, 21. It's times 2 plus 1, times 2 plus 1. That's a horrible pattern to have to deal with. But I invite you here for this other part, showing that every number shows up, to pause and try to figure this thing out. For next, take 20 minutes now that you have this. And this is the big idea. The big idea is namely that we have now, this is a wonderful problem, mind you, just because you have to really write down, what I want to show you here. I made a mistake in shooting this video and I had to and it was a lot of, I'm probably going to be shooting this for an hour in total, and I'll cut it down to get rid of the mistakes. But the reason I want to show you this video is because this is what it sometimes takes to solve competitive mathematics problems. You write down the first 31, 32 members of the series so you can figure out what's happening, because at the beginning you have no clue what's happening. And now once we've written down all these different pairs, now we have some semblance of a clue. And now what? What are we going to prove? Well, this is 21. Then, and once it's paused for 10 minutes, you figure out this is the number of the form 10101, and all the way to like zeros and one alternating, and it either ends at a 0 or a 1 in base 2. This is like what the number is in base 2. So now you have to like say, like, do I need to prove this really? Do I need to look at these cases? Like, is it a 1? Is it a -1? Is it this? Is it that? I don't care. And you can actually go ahead and just like prove this in base 2, that this is actually what the number, the index which gives you an at the beginning, which gives you an the first time. So for 5, it's between 16 and 32, 2 to the n minus 1 and 2 to the n. So it's the number in binary which has n of these digits. And that's actually a bit unfortunate for me because I don't want to deal with binaries here. But we can prove this also via induction. And we can say if j was odd, such that aj is equal to n and j was between what's called 2 to the n minus 1 and 2 to the n, then the numbers, so then what will we have? We will have 2 times j, and that's really it. We have 2 times j's between 2 to the n and 2 to the n plus 1 and 2 to the n. And then what do we know? Well, we know that for numbers 2 to the n is equal to a 2. And then we know 2 to the n all the way till 2j. The odds will alternate. Now, because j was odd, 2j minus 1 is going to be, actually, I won't just say that j is odd. If j is, I'll prove via induction. If j is odd, it's congruent to 1 modulo 4. And if it's even, then j divided by 2 is congruent to 1 modulo 4. That will be the inductive claim. You can just like add inductive claims once you see like, wait a second, I need this thing as well. So then I know that 2j minus 1, because 2j minus 1 is like 2j is when I add a 0 here. And then minus 1 is like just messed up. 2 to the j plus 1 is going to be 1 modulo 4, because j was odd. Because j was odd and j was congruent to 1 modulo 4, so this is going to be congruent to 1 modulo 4. Actually, I'm just multiplying by, okay, this is 1 modulo 4, so this means this is a plus. 2 to the n plus 1. Oh, this is also a plus. 2 to the n plus 1 is 2 to the n plus 1 is also a plus. So I have, when I pair these odds, they'll cancel out. And I'll have the difference between this one and this one will be the same as the difference between 2 to the n and j. And we know that from induction, because j is equal to, aj is equal to n, that and 2 to the n is equal to, so 2 to the n minus 1, that's always equal to 2. You know, now I'm a bit concerned. It's equal to 2. And j, that's going to give me that. It's going to give me 2j is equal to n as well, not n plus 1. I am missing something here. I'm just trying to like figure out now, what is it that I'm missing? The odds cancel out. 2 to the j plus 1 is a plus 1. This is a minus 1, so wait. 2 times 5 plus 1. No, 2 times 5 plus 1 is a, I said j is odd. 2 to the 5 plus 1 is equal to 1. Wait, it's odd. Wait, it's odd. 2 times j is this. 2 times j plus 1 is, oh my god, this is 3 modulo 4. So this is minus 1. So the odds actually don't cancel out. But you have, so the difference between these two is going to be n minus 2. And then we have an extra plus 1 because the j's don't actually cancel out. We have an extra plus 1 here. And then that gives us like the induction like if j is odd. If j is even, it's, I would just like, you know, do inductively that it's of this form. If j is even, I have by induction that it's odd. And then I've proved that the even one is of this form. If like this j was even, then it was odd. So this was if j was odd. If j was even, it was of this form. I multiply by 2, add a 0, add 1. That's what this becomes. And now I think a similar argument-ish can be made, like aj is now, so j is between 1 and n. So again, I have numbers 2 to the n, what's it called, what do I have here? So from 2 to the, say, 2 to the n, all the way till 2j plus 1, if it's even, and these odd, and the evens, so it comes from 2 to the j for the evens. The evens are going to be the same as from 2 to the n minus 1 till j, and the difference, this is a 2. At aj, we have, by induction, we have, what's it called? We have n minus 1. Doesn't matter here, like, so n minus 1, the difference between these two is 2, so the difference between this one and this one is also going to be 2, like just the even ones, and they alternate. Let's see, what do I get it? I'm literally just checking what do I get here. A 5 is a plus 1, okay, so that means this is going to be a plus 1. Yeah, they alternate, so it's like a plus 1, minus 1, they cancel out, and then we have a plus 1, so we get the next one. Yay, done. I am done with this problem. It's a beautiful problem, but it's, you know, it's tricky. And I want to show you, like, even I have done this for a while, and it's, how do I figure this out? You can figure out how to write it down. I'm not spending more time on this problem, but it teaches. I'm a bit fed up because it took me a lot of time to do this, but I think it teaches you really a valuable lesson in problem solving, that sometimes like you don't know, you have an idea, oh, what could work, this could work, that could work, and then you write things down, and then you're just like looking for patterns, you're coming up with hypotheses. Is it this? Is it that? Is it this? Is it that? Fail, 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 and then congratulations, you get to a hypothesis that works. The mistake I made was thinking that the numbers, what's it called, 2 to the n, 2 to the n plus 1, were the same, like the odds evens were the same as 1 through 2 to the n. That was just wrong, flat out wrong. And that's why I needed to restart this after going at it for 10, 20, maybe 15, 20 minutes. And it's a beautiful problem nonetheless. And as always, thanks for problem solving.